TV. Today is Wednesday, and we're talking about manufacturing. And what we're going to talk about today is layering and print quality. And also on continuing on the yesterday and this series of 3D printing, um, I want to bring you the opportunity to open your mind, look at new avenue, see how you can start to think with 3D printing in your life, your business, in your projects, and how it can also help you to change your life. As we understood and as we experiment yesterday and the day before, um, what we saw and what we've been seeing is that, sorry, I had something that was distracting. What we saw is that we're working from the same base. We have source on Monday, Tuesday we have fixtures, Wednesday we have manufacturing. And what I'm trying to do is bring you to a process of operating and repeating so that you start to train yourself to to go out and also implement this in your life. This is not just about theory. This is not just about words. This is about you taking ownership and making sure that you're understanding it properly and you're using it properly. So manufacturing, well, manufacturing exists since we invented the round wheel, right? The pyramids, we had through times we had to manufacture different time housing, transportation. We had to manufacturing, process, uh, machinery. So lighting is the continuation, and 3D printing is, according to me only, is the next evolution in printing. It's funny because whenever I talk about 3D printing or additive manufacturing, uh, I always been, when I looked at futuristic movie, not really interested with the story, but interested on the technology, the how, where do they live, what do they drive, how things are made. And when I look at anything like Star Wars or even Iron Man, and I see these guys that have the shop and all the equipment and they're repairing spaceship, this is where my attention always been because I'm that kind of guy. I'm the kind of kid that we're taking clock apart and looking, and I was not at the level of putting them together, but already understanding that taking them apart needed a certain rhythm, certain technology. I needed special screwdriver. I needed this. I needed that, and I would do all in my power to get these tools and do whatever I could. So today I'm in the lighting business. I've been in it for 4 decades, and 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 I've been to the whole evolution from installing lights to designing lights to manufacture lights to help manufacturers to work with bulbs manufacturers, and this next step, which is additive manufacturing, is where my real passion sits, and where I really, really want to understand and start to put it together. I truly believe that factory will be automated 100%, lights out, and producing objects and products and machines that will be used for us to have a simpler life or to reduce monotonous, you know, steps so that we can use our brain to do something more useful. That said, in lighting, I think this is where it starts. So the basic of 3D printing is that we have these layers, and depending on how thin, how thick, how fast, how slow, how hot, how cold, it creates, and also the machine, the mechanic of the machine, that it is on a robot arm or is it on gantry system, or uh, we get that flexibility, and we're no longer attached to these massive press or these massive orders of material that are sitting on shelf and waiting to be transposed, and having to do all kinds of process, subtractive process, and having to deal with all the residue. And I'm going to say that, and I'll never talk about this again, because this is not what I want to talk about. I want to talk about the additive manufacturing opportunity that we have as a creator, that we are in lighting, that we are in automotive, that we are in space, that no matter where you are, even medicine, that there is an additive machine that can do parts and make something that right from your brain that you put on a piece of paper into a final product without having to go through this whole ecosystem. Now, if you're on that other side, let's say you're on the side of the ecosystem, and this is what today's lecture or seminar is about, is how do you prepare yourself for that? And where should you be? And what should you do? I'm not there to tell you what to do with your manufacturer, but I can guarantee you that if you're not prepared, you're going to miss the boat. And if you're not thinking about it and you don't know where to start, well, this is the perfect podcast for you today, because I want to take you from the basic and where you're going to be in a position to start evolving and building on it while you keep doing what you're doing, so that at some point you'll have some reality, you will have some affinity with what 3D and how you're going to integrate it into your business and take it to the next level. And I think if I achieve that, I'll be a super duper happy guy. And also what that will do is that will simplify my life, and that you will be part of the next evolution of manufacturing. So when we have a 3D printer, we're not just printing object. And again, maybe that's what we want to do. Maybe we want to take a printer and start printing different tools that are going to help our people to function faster. Maybe we want to print some fittings that we didn't have before because we want to retrofit the fixture. Maybe we want to print some packing because the type of fixture we have are very particular or very fragile, and we're spending a fortune on packing and storing these massive barrels and this and that, while we could be printing these special bracket on demand. And every time we have a lighting fixture that required to be shipped, we have this packing. So the printer is really there to help you to take a very boring task and bring it into something more practical. Now, we're talking about lighting, and when we start to integrate printing and lighting, now we're talking about shaping lights at a micro level. I'm not talking about building a whole factory and having everything on it. No, let's just see how at a very tiny scale we can start to implement, and how we could implement, and ideas of if you had a manufacturer, how could you do this with a gradient? Because yes, you can go out and then you can spend 10 million in building a whole factory, but the ramping up is very high. The technology is very high, and by the time you're ramping up, you're losing revenue, you're losing time, you're losing people, you're creating all these problems that you don't have and you don't need right now. But if you do it gradually and you do it organically, what's going to happen is that it's going to become part of your culture. It's going to become part of the way your company is operating. It's going to become part of your ecosystem. And then you're going to start to be known as the guy that has 3D. You're going to start to be known that the guy that can make things happen. You're going to start to be known to the guy, the go-to guy, because let's be real, in all the lighting industry right now, there is a very, very, very small percentage of company that are using 3D printing. And it's not because the technology is not there. It's not because the machines are not there. It's not because the materials are not there. It's because the adoption is the step for adopting is very steep. And also, there's misconception on, well, a 3D printer is very expensive. A 3D printer is very hard to operate. A 3D printer requires a lot of care and attention and this and that. Well, it's all true. I'm not going to say no. It is all true. But just remember, a couple decades back when you started your company, when you start working with manufacturer, how it was the same. I helped set up many manufacturing plants in lighting manufacturing plant and others. But let's focus on lighting. Just the evolution of moving from incandescent to halogen was already a big thing. And because we weren't used to have such a small source with a lot of heat. So the testing, the heat management, the material, the sockets. Oh my God, the sockets. At the time, the halogen technology was mostly coming from Europe, and we had to deal with products from Europe. So, and we didn't know what they were. We didn't know which one was good, which one was bad. We didn't know that some of them were certified, some were not. And then if you, let's say you manufacture 100 fixtures with the bad socket for an MR16 that were overheating and the spring were, not working, and then there would be corrosion, and then the fixture would start flickering, and oh my God, I'm skipping this whole step. And power supplies, oh Jesus, what a hell. But we had to adapt to that. And then that was not enough. Then we had to create casing for it. Then once we had the casing, and the regulation were always increasing. From year to year, we would have more and more regulation on heat management, on glass, on how to protect the source. And then the manufacturer had to put a glass because some people were sticking their fingers in and burning themselves to the first degree. They were lighting up cigarettes, lights were exploding. I mean, it was an evolution. Then we get the compact fluorescent. Oh my God, same thing, right? And then we get LED. So having gone through this, 3D printing is just another evolution. Another evolution. And what I learned from all these different evolutions is that what you want to do is that you want to start at the beginning, right when it starts. I mean, I've been working with 3D printing and promoting it and developing it and for 15 years. So you're already late. But let's say in the lighting industry, we don't have many. The other day I was making a research. There's a couple company that made stunt, marketing things. They say, oh, we're doing this and we're doing that, and that's it. But let's start to think like somebody or a company that wants to get in and wants to catch up. So basically, we're not in it to change the industry yet. We're not in it to work with everything that needs to be done. We don't want to change all the plant. What we want to do is create a unit that will start to explore and then implement slowly. And you're going to do this with different program, trade program, work how do you call this, workman's compensation, I mean, uh, uh, VA, all kinds of programs that have money in right now that are basically, uh, most people have tried or look or explored, but they never did anything with it. So how are you gonna do tax breaks, um, grants, and all of that? And you probably gonna should start with one machine. Go out there, buy a machine. Good. Look at the review. Don't spend too much time. Just buy one, because this is where your personal training is gonna start. And then you're gonna make a little survey in your staff and say probably somebody's already working with a 3D printer in your staff, and you're gonna bring one machine and you're gonna say, okay, let's look around and let's find one thing that we can do with that machine and document it, right? So you're gonna buy a machine and you're gonna start looking around, and maybe you need a bushing. Maybe you need a little bracket. Maybe you need to do a little clip, whatever. Doesn't matter. And then you're going to start documenting, looking what material you tried, what material you didn't try, and what also you're going to have another clipboard for the machine, because you're going to learn where the weak points are. You're going to learn where the machine breaks. You're going to learn what part of the machine you're going to have to watch, what part of the machine that are more fragile, which one are like a tank, they go and they go and they go, and how you maintain it, and how often do you maintain it, and what happened at what hours of utilization, how long does it take to print a file, what's the difference between a 5-hour file and a 15-hour file besides 10 hours, the quality, different quality. And you're going to gather this data from the machine, you're going to gather this data from the parts, and you're going to gather this data from the person, so that now you can start thinking in a very, very objective way of 3D printing. What's happening with 3D printing? How is this gonna be scaled? Because the beauty of 3D printing is that you can scale it indefinitely, and you can automate it indefinitely. It's just a system, and but if you don't understand the basic principle, and trust me, I watch many YouTube videos. Nothing in these videos was compared to buying a machine. I'm a bit extreme. I bought 4 and I said, if I'm going to have the trouble, I can handle 4 at the time. And I replaced these 4 machines twice, because I didn't know. I didn't know how to repair them. I didn't know what to do, how it works. First, the communication line with the manufacturers. I didn't know how long it take before I get my parts back, because they say, oh, we'll send you parts. Right. You got a production to do, and the parts arrive 2 weeks later. So that means that you are 2 weeks without having the parts for the machine. And yes, you can buy it on YouTube, not on YouTube, but on Amazon or on their site. But the bottom line is that you need to experience it for yourself. And again, when I say you, could be one of your employees, could be somebody in your company that already has affinity, and that you can put a couple hours a day or a couple hours a week or a whole day a week and devote it to that, so that you have a continuation of information, continuation of product, continuation of production going, and consistently testing. And I can guarantee you that after a couple months, you're probably going to buy a couple more machines. You're probably going to try. You can buy used machine and try to fix them and this and that. And you will have experienced the whole ecosystem. And now you're going to have your own opinion. You're going to have your own idea. You're going to have also took all the drama out of the company because they're going to have lived with it. They're going to see it. They're going to understand it. They're going to have been through the evolution and probably contribute to the enhancement and the sharing of information and file so that you can start now thinking about implementation. So from nothing, in a couple months, you'll be able to start thinking, okay, now I have something. I see the report, right? I see the report. I see the product. I have a whole evolution of product. We tested the product, and then we test the different material, and we test the time. We test also the maintenance. We test the break points. So you have a lot more data than just watching YouTube video, just hearing from a sales pitch from a salesperson, and also having somebody telling you that you cannot use it. Because having it in your proximity, having different exercise and products and different build up done, what's going to happen is that you're going to have the practical application to it. And let's face it, you already built the manufacturer. You already built a whole system that worked. This is nothing different. The scaling of it, the financing, all of that you know already. The only thing you need to find out and realize for yourself, and that's why I'm putting pressure and I'm giving you all this data, because I did the same thing. I did it for myself. I studied the material. I try to print very different shapes and crazy shapes, and I look at the different behavior of light. I practice. I order all kinds of source, and I just had some raw print and putting lights in it. I also work on different finishes. I work on how I could finish the surface. I sanded it. I warmed it up. I torched it. I mean, I did probably everything in the past 15 years. I tried it. I probably try more than anybody else. Why? Because that's the kind of guy I am, and I wanted to see, and I didn't believe anyone. And nowadays I see, I'm at another level where, like right now I'm thinking more in automation. How are we going to automate this? How are we going to make this to be more Tony Stark than before? Because I like this idea, and I have the bandwidth, and I study in robotics and integration and all of that. And this is where I'm going with it. But and eventually I'll talk about that too. But for now, I'm still in the research process. The other thing that you will experiment is by having different printers, one printer, and trying one technology. Now you'll have more. You'll be more willing and have the knowledge to now expand into a different technology. Let's say going in resin, and then you'll maybe ready for metal. So the evolution will all start from the beginning, and it's the same process. And then what's going to happen for you is that now you're going to start integrating these parts, plastic with lens and metals, and then hardware and software, and we talked about logic boards, and we talked about all kinds of stuff. Now you'll be more equipped to be able to start testing, integrating, also the finish. You'll be able to have a more precise vocabulary on finishes, on the different technique used for assembly. Because yes, you probably have a very wide vocabulary, but when we start thinking about additive manufacturing, it is a different beast. It is a different way, and it gives you uh, technique and technology that were not you couldn't do before, because the way that the parts is done never been done like this before. So it opens a brand new area as far as assembly and fixtures and technology that was not there before. So the fact that you're adopting 3D printing slowly, and you're learning it and you're practicing, and you're applying your already vast knowledge to it, will be at the beginning little slow. And if you document it as you go, what's going to happen is that you will create these hacks, these operating procedure, these manuals of different steps, because it is the same process to work on a 3 foot by 3 foot by 3 foot 3D printer than a one that does 6 inch by 6 inch by 6 inch, except everything is bigger. Materials, spools are bigger. You know, power is bigger. The time is longer, and. But once you master this, and you master then it's just a question of scaling. So by adopting it and starting small, building a little team, a little unit, involving people into it, making sure that they're collaborating, and you can create this as a game. You can start doing some bonus. You can start doing some ideas. There's gamification you can bring into that, and 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 then you'll start seeing the workforce embracing it and looking at it and say, well, you know what? I don't think I'm going to lose my job over a 3D printer, because the 3D, there's things that the 3D printer cannot do. And although we want to try to move towards a lights out factory, meaning that it's a Tony Stark, you program everything and you put it in, we're light years from being there. And all the jobs, and I was listening to somebody telling me that yesterday, that they predict with AI there's 90,000 jobs that are gone, 90,000 job titles that are going to disappear, but there's 190,000 new job titles that are gonna evolve, that are gonna be created. So basically, what it says is that we're shifting. So if you have a traditional job and you worry about losing it, well, guess what? There will be stuff that you can learn and that you can implement and that you can do, and you can evolve. And guess what? It's also going to be more technological. That means that you're going to be making a little bit more money. So it's all in your favor, and especially if you have employees that are smart, which most companies have. Even the janitor is a smart guy. Once you start to involving them in the process, their level of smartness and their field of expertise can contribute to that section of your fabrication, and another one can, and then another one, and then another one. So basically, you're building this squid of expertise, and you're asking your employees to join that squid with whatever they have, so that you're bringing your evolution of 3D printing further and further every day. Wow, this is amazing. But how does it, how, like, how do we do that? How do we arrive to that? Well, my process, and I can only tell you about me, because everybody is different, but what worked for me in the past is that I come with a very heavy academic background. I always been involved in education as long as I remember, for over 40 years. Even when I was at school, I was involved in the school. So for me, schools are a good pool to go dig in talent. Um, and then you have makerspace. You have all kinds of other space that we're going to look on the ecosystem next week. But now let's focus on manufacturing. So schools are a good for a start, a good start. You can start by implementing maybe a contest, and a contest with a school, and what you are, you buy a couple machine, and now they're 300-400 bucks, maybe $500, so a couple $1,000, and then the winner wins. Let's say you buy four machines. First one wins two, second win one, and third one, wins one or whatever. And then you start going to school and you start seeking for talents. And of course, they need to be in the company. So you set up a little corner, and then you tell your employees, well, this is going to be that, and you guys, whoever participate is getting points, and after the week, we're going to get a prize. We're going to have a raffle every time you bring an idea, or every time you bring a parts or something you contribute to the motion, you get a ticket, and whoever has most ticket, wins. Or we have a raffle and we have a wheel, and you create a whole game around it so that everybody's part of it. And since it's under the educational umbrella, we're working with this elementary school or secondary school or this part of the university. The friction will be less, and also it's very good for your PR. You take some little YouTube video, post that on your website, and you'll see how it evolves. And you start small, and then you do some testing, and then you start printing some little forms, and you test them, and then you have the employee, and then you build it up. And as you build it up, you use that little R&D for experimentation. You don't talk about final product. All you're doing is you don't put pressure on product, you don't put pressure on your line. All you do is how you can complement this. How can we experiment that? How can we experiment this? How can we do this in color? How can we do this in different shapes? So design school, engineering program, how do you call it, a STEM program, all those are good match for you to start training, and then and do different things, and also develop some ideas. So once you can do this and you start working at it, um, 1 second, I have a very important call. I'm just gonna say no, I can't. Sorry. Normally I put everything on pause, but tonight I'm giving a seminar, and it's in Morocco, in Africa. So they're trying to reach me, so I'll call them after. So to finish up on that, pool, and that idea of having a little R&D and integrating students and employees, and create a, now you start engaging, and you start creating initiative. And by doing contests with students and design challenge and raffles, and you're start to modernizing your workforce. And there's even a lot of incentive to do that. The government, the workforce program, they have a lot of things. There's all kinds of online course that your employees can start to take. And now you have a machine, and they can have a bonus if they practice themselves. So do you see that there is a way to implement all this, and the idea is that you start slowly, and you just go and you make it. So tomorrow we're going to talk about No, tomorrow I'm not here. I'm out of town. Friday, we're going to talk about the ecosystem. And what I'll do is I'll bring to you ideas of where to go to get some resource and different people and different ways that you can start bringing this into your company. So I know that was a lot to digest, but if you're rewatching the video, you look at the and you start to, and if you have any question, you can get in touch with me. That's not a problem. Uh, we'll and also I'll bring some more stuff next week. So thank you for being there, and I'll